This mini lecture provides the definition or the computation of this mathematical constant E. And here, I want to go over two most commonly used definitions or derivations of this magic number E. Okay? So the first is E is equal to the limit of a function raised to the power of n. And what is that function? 1 plus 1 over n. Okay? And as n goes to infinity, then we will approach infinitely this mathematical constant E. Okay? And this definition or computational formula was derived by Jacob Bernoulli while working on compound interest, assuming the interest after a year is 100%. And Jacob's question was, if we want to collect interest on a quarterly basis in a compounding way, what's going to be the final number after a year? Well, the n here is going to become 4, and exponent going to become 4. So after we carry through the computation like that, we will get the final number that is in a factor format. And let's go through a couple of examples. So let's say n equal to 1. Then we can plug in 1 here, and in the exponent, the final factor or number is 2. Let's increase n from 1 to 10. We can plug in 10 here, 10 here. We'll get approximately 2.594. And let's further increase n from 10 to 100 by 10 folds. We'll get 2.705. So it is approximating this E, right? Mathematical constant. Another way to compute E or derive E is to use a infinite series. So here we have a summation, and we have this non-negative integer k from 0 to positive infinity. And here the function for the summation is 1 over the factorial of k. So what is factorial? Okay, factorial is just a product of a series of integer numbers. So let's say here we have this k, right? Factorial. That would imply we're going to multiply a series of numbers beginning from 1 to k. So here, for example, k factorial is equal to 1 plus 2 plus multiply by until this kth integer. Okay, so let's say 3 factorial is equal to what? Equal to 1 plus 2 plus 3. And 11 factorial, what is that equal to? Is equal to 1 multiplied by 2 multiplied by 3, and it goes on, multiplied by what? 10 and multiplied by 11. So that is the basic definition of factorial. But once we understand the definition of factorial, then here the computation is going to become much more straightforward. Here I can give you an example. So let's say k equal to 3, right? So if k equal to 3, we just plug in k here, and k is from 0 to 3, right? And this summation becomes 1 over 0 factorial because k begins from 0, right? Added to 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial, which amounts to, roughly speaking, 2.667. And this definition says, well, as k goes from 0 to positive infinity, we can very, very closely approximate, finally, hopefully, we're going to reach the value of E, which is a rational and transcendental number. So hardly can we say we can reach that precisely. But this is the second definition or computational formula for E.